The volume builder inside Cinema 4D Release 20 accepts any tangible object as a valid input and creates a volume by evaluating some object-specific parameters. In this video, we will see what types of objects we can use and what their specific parameters are. In this scene, I have prepared a number of objects and I've dropped them as children of a volume builder. And there's a lot of animation and lots of different types of objects. So let me stop this and let me go and activate my volume builder. Let me drag this up here. Now you can see that everything has been volumized. And let's just go and turn everything off. So I'm clicking and dragging and turn everything off. Now, one thing you need to remember is that the objects are somewhat similar in their attributes in the sense that all mesh objects have the same parameters, all spline objects have the same parameters, with a small exception, all particle objects have the same parameters, and all volume objects have the same parameters. And you cannot use objects that are not tangible, so lights, cameras, and a floor object and deformers without being assigned to an object will not work. But everything else pretty much will work. So very quickly, let's go and activate them one by one and see what's going on here. So I have this little doggy here, and it's a mesh object. And when I go down here, you will see it says use mesh point, which is off by default, and a mesh point radius, and optimize and close holes. Let me open up a couple of scenes and show you what these parameters are. The use mesh points is a very simple parameter that just tells us that instead of using the actual object as a volume source, just use the points. So now it's just creating blobbies wherever the points are. So if I go to the cube and I increase the number of points in some of the segments, you will see that we get all these little blobbies, and we can use them in all sorts of contexts with more complex objects. Now, one more thing, we can change the radius of these points and make them look any way we want them to, and you can see that they're merging nicely when they come together with each other. And they're going to create a nice smooth mesh. As far as the optimize and close holes, here's what happens. I have this nice head here, but it has some holes. The eyes, the mouth here has a hole, and under the neck. Now, if you volumize this, this creates a bit of a mess. And if I make this a mesh, it's a mesh. So the reason is because it has holes. The SDF doesn't know how to create this. It needs a watertight, a closed surface. But luckily there's an algorithm within the volume builder where if you click optimize and close holes, it will find those holes, it will close them, and therefore it will be able to generate a proper SDF. So moving forward, you will see that a primitive cube or a primitive cone, or any primitive for that matter, a torus, or even a generated object, like a lathed object, or even an instance of an object, or even a hierarchy with objects. So 4 cubes under a null. We drop the null here. We can only see the null. And let me show you something about these mixed hierarchies. So here is a mixed hierarchy. It's a null with 4 different types of objects, a matrix, 2 primitives, and a primitive spline. If I select it, I can only see the null, but you will see here that we have a variety of attributes, some pertaining to the actual mesh object, so the sphere and the cube, some pertaining to the spline, the helix, and some pertaining to particle objects, because the matrix is a particle object. And I'm just going to show you in a bit exactly how this works. But yes, you will get all the types of parameters you need underneath when you select the parent objects. Just a little note about mesh objects. You can use instances and they will work fine. So this here is an instance of this, and you can see that it's got the deformation on it because this is a torus that's been deformed, and you can see that it comes in perfectly as a valid volume input. So let me turn everything off and move to splines. So I'm going to select this editable spline. Now with splines we have the following thing. In order for the volume builder to create a spline, it needs to sample something. So if I make this quite low so we can actually get a better resolution, what you will see is that for splines, it first puts some spheres on the spline to create a thickness, to create a skin, and then actually this becomes an SDF. You control the density of these spheres by the density parameter. So if I make this 0.05, you'll see we have even less, and you may want it to be this way. Maybe you want to model an intestine. Or you make it higher and then it puts more spheres. Just make sure you don't put too many, because then you're going to have more calculation time. Not too much, but unnecessary calculation time you can avoid. And then we have the radius. So these are the two parameters that apply to splines. So the same parameters apply to the helix. So let's go here. Here it is. Go to the helix, select it, increase the density and decrease the radius. Now with the radii and wherever you have radius or things like that, just make sure that the voxel size is small enough to accommodate for that radius. So for example, if I set the radius to 1, everything is good because my voxel size is 1. But if my voxel size was 5, nothing will be created because the radius is much smaller than the distance between two voxels. So make sure that the radius you're using in any of the object inputs and the voxel size makes sense. So if you make this 2 and make this 2 or 3, it makes sense. But make sure this is not much smaller than this. So the tracer is a very particular type of spline. It's actually a spline that's been generated by tracing something. But because it's a spline, it has exactly the same parameters. What I'm doing here is I'm using a standard particle emitter, and it's tracing the particles. And you can see that it creates these squiggly things. I'll make this 5, I'm going to make this 1, and I'm going to press play again, and you can see we can create fantastic effects. Now the Mohs spline is a spline, but what you will see with the Mohs spline is the following thing. I'm going to press play and you can see that it's properly animated. Now with the Mohs spline, we only have density, we don't have the scale, the radius, and there's a very good reason for that, and let me show you what that is. The Mohs spline is a very powerful spline because it abides by the rules of MoGraph and can be controlled using particle modifiers, and it can even use effectors, which gives it extra power. Now the reason why the Mohs spline doesn't have a radius as a parameter is because the spline itself has a scale parameter. And because it has its own default scale parameter, then we don't need to define it in the volume list. And the good thing is that, just like in this case, I'm using a step effector to change this scale just based on the ID. So this propagates properly to the volume builder. So let me just go and make the density 0.1 so you can see what's going on. There you go, our little spheroids. And you can see that they are small and they're growing. And that is because the Mohs spline has that radius in the form of the default scale parameter, and you can do whatever you want with it. Now we're done with splines, let's move on to particle systems. So the standard emitter, let's go and find it over here, and you can see that each point, each particle is a dot, so we can set its radius. There you go, I can press play and you'll see the particles moving. It's just the same standard emitter I was using in the tracer object, just to save some space here. And here's something interesting, the velocity scale and the use particle size. Let me show you how these work in a separate file. So here we have these, what are these? These little baseball bats moving. But basically this is an exaggeration of what we're going to show here. So the emitter is set to tangential, so the particles are actually turning towards the direction they're moving. And it's just a couple of particles. And I've set the n scale to 0. Now let me make their lifetime 100, make it a bit shorter. Now if I go to the volume builder and select this, I'm using the particle size, which means that these are going to get smaller as they grow older. Now let me do something. I'm going to set the velocity scale to 0, and they're going to be now spheres, but they're getting smaller because I'm using the particle size. And this particle size, it actually respects the scaling that the emitter is creating over here, the end scale. The other thing I need you to pay attention to is this velocity scale. These are moving and they have a particular velocity at every frame. That velocity is a combination of how fast they're going and where they're pointing. And if I make this 1, for example, you will see that that velocity becomes a parameter that allows them to elongate. Now, this is an exaggeration. You can do this as an effect, but it doesn't have any real practical use. But if you use a nice little modest value like 0.2, you can create the sense of droplets. And that is interesting. The same parameters you can find in the matrix object. So use particle size and the radius, but we don't have any velocity here. And the particle size is whatever the matrix scale is, and you can use effectors to change that and so forth. Very, very powerful and simple stuff. Finally, we have the thinking particles. Now you can see that this is linked, and I haven't put it in the hierarchy because we don't have any tangible way of using an object and put it in the builder. So in order to do that, very quickly I'm going to show you, go to the simulate, thinking particle settings, and just grab this group or any groups you have for that matter in the list, and they will be linked, and then you can use them to create whatever you want. And I'm going to show you an example of something fun. In this scene, I have a matrix object which is generating thinking particles on a helix object. And that's just about it. I'm using the thinking particles, which I got, as I showed you before, from this group here, and I've linked it in the volume builder. And what I've done, I'm using the particle size. And all I've done with Espresso is I've just created these particles to be large here and smaller as they go to the end. And if I go to the builder, and if I just nudge a frame forwards, you will see that this is the volume I am getting, and I can mesh it if I want and so forth. Let's turn on these. So you can see that just by using thinking particles, you can create astonishing effects by scaling your particles up and down and putting them in any configuration you want. We are going to be creating content about all sorts of techniques where you can use these to create magnificent effects. A cloner object is nothing more than a mesh object, so it has exactly the same parameters as any other mesh object. And of course, we can use volumes as inputs for volumes. So you can see that this one here is just another volume builder with a figure inside it, and we are re-volumizing it over here. And this over here is just a fog volume of the Stanford Bunny. I downloaded from the internet, and it's nothing more than a density field. So we can even use volumes inside volumes to create amazing effects. The volume builder can generate fog volumes from objects in a similar fashion to SDFs, but because fog volumes are slightly different than SDFs, there are a couple more attributes for input objects and different blending modes. In this video, we will take a brief look at those. The process of generating fog volumes is identical to the SDF. We can drag any supported object in the volume list, and all we have to do is switch the type to fog. What I'd like to focus your attention to is that although all parameters of each object type are the same as the SDF, we now have an extra two attributes: the inside voxel falloff and the maximum voxel falloff. These parameters are similar to the SDF's interior voxel range and define how smooth the transition from the surface